Hi, Viper chemistry students. We're going to try this. I'm going to try to show you the screen and then try to show you some electron configuration notation here. So you see up on the screen is the off-ball principle, and you'll see that on your worksheet. But let's go down through some of these. I thought we'd start with hydrogen. Now, hydrogen, one of the things you have to do here is you have to decide, okay, how many electrons are in each element. And so in this case, hydrogen is the very first atom. And so it has one electron. So up here, you would start with one s, and every orbital can only hold, or s orbitals can only hold 2 electrons. So hydrogen would be 1s1. Okay, so that would be the electron configuration for the element hydrogen. Now, when you get into like the p orbitals, there's 3 pairs. So in the p orbitals, you would have a total of 6, 3 orbitals that could hold 2 each. Okay, so anyway, let's look at that. Carbon, which is, see here, I'm going to switch over to the periodic table here real quick. So when we go to the periodic table, then here is carbon. Here it's element number 6. Okay, and so that means it has 6 electrons. So when we go back to our off-ball principle here, our diagram, we would count up 6 electrons, and that's where we end our notation. So we can fill up the 1s, so that would be 1s2. And then it comes around here to the 2s, so that would be 2s2. And then we go back around to 2p. Now there's 2 electrons left because carbon has 6 electrons, so that would be 2p2. So when we count those, that adds up to 6. Okay, so that is the electron configuration notation for carbon. Now, let's go a little bit higher on the scale here. So we'll erase these. And let's say we go to, let's just pick out one, go back to the periodic table. So let's just say we pick out one that's down here somewhere. So let's just say chromium has 24 electrons. So it's atomic number 24. So we'll just start with chromium here. And it's got 24 electrons. Okay, so that's what we're working with. So as we work our way through then the guide here, the off-ball principle guide, we want to use up 24 electrons. Okay, so it turns out that as you fill these in, we would have 1s2, 2s2, 2p6, which is saying that, go back to the periodic table, because really when you're doing these notations, you're kind of working with both of these ideas. So you got to basically, this is your 1s1, your 1s2, and then this comes back over here to 3 and 4, which means that that's your 2s1 and 2. This would be your 2p6. So that's where we are so far. So we're up to neon right now. So now we'll continue. And what we would do is we would now go to 3s2. So I might be going off the board here, so I'm going to come down here. So 3s2. And that really brings us to right here. 3s2, 1 and 2. But we're going for 24. So we then have the 3p6, which just means that all of these right here are full. So this is the third energy level here, and this is 3p group. So it'd be 3p6. And then now we're going down here to 4s2. So that would be over here. And we're going to try to get to 24. So we're at, after 4s2, we're at 20. And so now that we are going to the next part, then that becomes 3D. Notice it's not 4, it's 3D4. So what happened there? Well, you've got energy levels that are numbered over here. So we have the first energy level, the second energy level, the third